We're getting a sense now of how functions capture modularity for us. They capture this notion of an abstraction that we can use it. And we're using this environment idea to help us understand how parameters get passed around, how they get bound, how they get used. And we've seen we can have local bindings for names of variables that are different from global bindings. And the system doesn't get confused. Let's do another example to look at what happens when we have multiple function calls. And so for here, I've got a simple little example. I'm going to define square. That's a very handy little procedure. It says, given something, let me multiply it by itself. Let me multiply it by itself. Return that value. And then I'm going to write a somewhat strange little procedure. I'm going to call it 2 power. And the idea is I'm going to take two numbers, x and n, and I'm going to raise x to the nth power, where n is itself a power of 2. And I'm going to do it with a simple loop. And the loop says, as long as n is bigger than 1, I'm going to take the current value of x, square it, and rebind x to that value. And I'm going to take the current value of n, do the integer division with 2, which of course is going to lose any remainder, but since n is a power of 2, it's just going to reduce it to the simpler power of 2, and rebind n to that value. So I'm going to square n and reduce n by a factor of 2. And it's a little bit like saying x to the n is the same as x squared to the n over 2, which is the same as x squared squared to the n over 4. And it's just giving me a quick way of doing that computation. When I'm done with the loop, I'll just return the value of x. Okay, I want to see what happens when I run this. So I can certainly load that, and if I go over here to idle, I've got those functions and I've loaded them in. And so in fact, first of all, I can certainly do square. If I square 5, I get back 25, and if I square actually something else, I get back appropriate things. And then 2 power, if I wanted to do this, I could do a 2 power of, for example, 2 to the 8th, and it gives me back 2 to the 8th power. Sort of what I'd expect. What I'd like to know, though, is if I, again, as before, if I set up x to have some value like 5, and I set n to be some value of 1, and I now call 2 power of 2 to the 8th, I should still get, I'm sorry, I didn't give it the right answer. Let me give it 2 power of 2 to the 8th. I should get back the same value. And we've seen that before. We're not going to get confused by the bindings. But we got multiple procedures going on. So let's look at what happens. So if I evaluate in Python these two procedure definitions, they create for me bindings of the name square and the name power, and they're both to procedures, which is great. I'm going to stress again, the body of the procedure is just text. There are no substitutions in for x or n there. I'm simply creating them as text. And I've now done a local binding for x to 5 and n equal to 1. So at this stage in the computation, this is what I have. Okay, just like before. Now, let's move on a step. Let's look at what happens if I were to call 2 power with arguments 2 and 8. And to be very careful about it, evaluating 2 power gets the binding of 2 power, which is this procedure. And that invocation creates a new frame. It's going to inherit from where the procedure says it should inherit from, the place where it was created. And inside of that frame, I'm going to take the parameters x and n, and I'm going to bind them to the values of the arguments that were passed in. Technically, those are evaluated up in the global environment as 2 and 8, but I've now got a binding of x and n to 2 and 8. And now I'm ready to start doing the computation, because relative to this frame, I'm going to evaluate this body. What do I have here? It says, let's go through the while loop. While n is bigger than 1, which it is, first thing I'm going to do is I'm going to square x. Remember, I'm in this frame, and I say, what's the value of square? So I need to add something here. I don't have a binding for square in this frame. But because it inherits from this global frame, I can find a binding up there. So if there's not something locally here, I basically go up and look for the binding up there. So square is itself a procedure. Aha! That says create a new frame. This is coming from the invocation of square, in which I take the formal parameter for that procedure, and yes, it's x once again, and I create a binding of x there to the value I had here. Remember, I was asking for the square of x in this frame. So that binding becomes the binding for x inside of square. And then relative to this frame, I actually evaluate square. It says take the value of x, multiply it by itself, and return it. I know there's a lot going on, but it's important to see how those different frames come up. I've got a I've got a frame coming from calling square. It is being called with the value 2 as the local binding for x. I multiply it by itself and I return it, and that of course is going to give me a 4. And that's what I get. I get a binding of x equal to 4. Right? This frame is now going to go away because I no longer need it. It came around, it was around because I had square. And the other piece it says is now take n, which was 8, and rebind it to be n divided by 2. So I've now got a new local frame here. Notice this is capturing a computation. I've gone from 2 to the 8th to 4 to the 4th. Cool. That's what I'd like. Let's see what happens. I go back around that while loop. Okay? N is still bigger than 1. So what does it say to do? It says get square, which I find by going up and finding that binding, create the frame, and notice again it's bound by where that says it should be bound. And inside of there, this procedure object says bind x to the value passed in, which was 4. It's getting that value of 4 from here. And relative to that, execute square, which multiplies x by itself and returns 16. And that's going to be what that gets bound to. And then I'm going to take n and reduce it by 2. So in fact, when I get to this stage, I now have a binding locally here for x of 16 and n of 2. And you can see it's doing the computation I like. This frame, again, is going to go away because it was what I used when I did that previous call to square. So what I want you to see is that each call to each procedure creates its own frame. It inherits from the environment where the procedure said it should. And locally, I'm still keeping track of this. So if I, in fact, go one more round around, again, I'm going to come to square here. It calls square one more time. That binding of x comes from what the square procedure should say. The value passed in is the value passed in from where I'm doing the computation. I do the squaring, and I get one more stage. And of course, now when I go around to the while loop, n is no longer bigger than 1. And I'm just going to return the value of x. And remember, this computation is taking place here. And so the right value of x gets returned, which is 256, and it gets printed out. I understand there were a lot of frames going on, but mechanically, you can see that those rules exactly describe it. Each local procedure has a local computation involving x. And in fact, one of the things you can see now is that this clears up that potential confusion about who's dealing with which version of what parameter. So, let's capture that. Notice how each call to square created a new frame with a local binding for x for square. The value of x in the global environment was never confused with the value that was being used for square or the value that was being used inside that iterative loop inside of 2 power. That value of the call to square is different from that binding, in fact, for the value inside of 2 power. So each one of those was kept separate. And as a consequence, these rules make it clear that we can mechanically keep track of the right value. And the other thing this does is it lets us go back to that earlier issue, which is, can I reuse the same variable name? So I can, in fact, have the same variable name in different procedures, because the rules for invoking the procedure keep track of which value matters. If this is confusing to you, walk through an example again, just to see for yourself how each procedure call creates that local context, that lexical scoping that captures what versions of the parameters are important to each computation.